Hello again, this is the course of data structures and algorithms. We are going to learn one more concept about the data structure, which is called as hash tables. So in this PPT, we are going to learn about the concept of hash tables. So the hash tables have also another kind of terminology, which is hash function. And the last one, we will deal with the collision handling. So what is hash table? With this figure, maybe you will not really understand the hash table, but it's kind of list in different ways. Okay? And the other literature, they mention it is a kind of map. Why it is a map? Because in particular values, we can indicate the key. So the key is the index as like mk. So the k is representing the index and m is map. As a mental warm-up, so let's consider a restricted setting in which a map with n items uses keys that are known to be integers in a range of 0 until n minus 1. So let's say this is the this is the so those are the keys. Okay, it's similar like list. Okay? You have the keys index 0, 1, 2, 3 until n minus 1. And then for every values in the particular index, yeah, you can put any values or you can just put it blank. So the idea of the map is also the same. We have the key and the value, and the key, you can just think that this is the idea of the map when the key is related with the integer values. Now, if we have more general kind of keys, okay, if you just think that the map is having a key, and now you learn about the key is 0, 1, 2, 3, 4, and so on. Okay, yeah, it's easy. But what if the key is not integer? Okay? What if our keys are not integer? It's not from 0 until n minus 1. So the hash function is used to map the general keys to corresponding indices in the table. So you have the key, which is representing something, for example, the social security number, or maybe in Korea you have 등록증, 등록번호. Okay, so that kind of number, that will be the key. Actually, it is your key. But if you have those key, how can you put it into the map? Yeah. So that's one kind of issue. Maybe you think that, okay, I just want to put into like a list. Yeah, that's also possible. But we have the hash table and hash function like this one for generating a better way for the storage of the data. So the concept of the hash tables, actually we have two, which is hash function and hash table. So the hash function, we call it the its. Okay? It will map the keys of a given type of integer into fixed interval. So you have a particular value. Let's say your 등록증, you have 4 plus 7, so you have 11 numbers. So the 11 numbers in your 등록증 or your ID card number, it is fixed. Okay, it can be regarded as a 0 until n minus 1. So maybe, yeah, if it is about the ID card, then you have 11 numbers, so it means 0 until 10 10. Okay, and we have 11, so the number will be 0, 1, 2, 3, 4, 5, 6, 7, and 10. So we can have the its or the hash function as x mod n. So you have the particular value of the interval, and whenever I want to put the values, so I just mod, okay, because I just have the value as n, and whenever I have any x, I just want to put it into the table. So we will learn more about this one. So we call this is a hash function for integer keys. Integer x is called the hash value. So later we have this hs is the hash value. And the hash table for a given key type consists of hash function and you have the array of size n. Okay. So when you have the hash table, it means you have the hash function, which is this one, and you have the array. So the array means how can you put the value into a particular index. So when implementing a map with hash table, the goal is to store item k, 0 in the index I. I is the result of the hash function. Yeah. So let's see. If we have the SSN, so SSN is the social security number, and I want to save this SSN into the, for example, this is the hash the list, and then I'm using the hash table to store all those SSN. So this SSN has a 9-digit positive integer. Okay, so we have 9. 9. So actually this is 10. No, yeah, should be 10. I don't know, 9 digit. So we have this digit, okay, and we are going to use the hash table, and the hash table for this purpose, okay, for this example, I just want to have this size is 10,000, okay, and the hash function. So you need to determine the hash function. In this domain, I just want to have the hash function as last 4 digit of x. Okay, so let's assume that this number is like the unique number, but you want to put the last 4 digit. Okay, the last 4 digit here, it will be the storage in the hash table. Okay, so if it is 1, then it is located in the number 1 or index number 1. If it is the last index is 2, 0, 0, 0, 2, then we will put it into the index 2. If it is 9998, then it will be stored in the index 9998. Okay, so that's the example of the SSN, social security number. So we can also think, yeah, maybe you will ask, what about if the number is something like, for example, 2J026 665, let's say 0001. Oh, so we have the same 0001 in the last 4 digit. Then, yeah, I can say that if you have this item, it will be here as well. Okay, because it's representing the ID 0001. So you can take a look on this figure. Okay, in this figure, so we call it, this is a bucket array. So the bucket array consists of 11 items. So 1, 2, 3. So there are 11 items, and in this 11 item, I want to put every item, like let's say this one is 1D, because I know it is 1. Then I just put it into the index 1. What about 25C? Okay, because we have only 11. Then what we can do is just 25 mod 11. What is 25 mod 11? 25 mod 11 will be 3. So I put it into the 3. So do you know why 25 mod 11? So we have the, yes, this one. So this is one example to indicate the integer keys. Yeah. So we use the mod function because I have a limited space, but the values can be any values. So in this case, because the value, the key is 25, so I just want to mod with the number of items that you can store. So the maximum number are 11, so that's why I just 25 mod 11. What about 3F? Yeah, I know that 3 mod 11 will be 3. What about 14? 14 mod 11 will be 14 mod 11 will be 3. So here, yeah, it is located in the index 3. What about 6? Okay, 6, it is in the index 6. And then what about 39? So 39 you can do again. Oh, sorry, 39 mod 11. So 39 mod 11, it will be 6. Yeah. Then yeah, I put the 39 comma C in the 6, and then 7 comma Q. So here, then you can see, right, there are 3 items in a single index. Okay, so we will deal with this one later. But first I just want to give you the understanding about the hash functions. The hash functions, it means I want to convert a particular value into an integer value that fits into the table. So we have another way to decompose some kind of particular values. Let's say the key, the key that you have is not integer. Okay, so like this one, the key is integer, so it's good. 1, 25, 3, 14, and then here is also values, and the key is a number. Okay, 0, 0, 0, 1. So it's a number. Then it's easy for you to understand about the key. But what about if the key, okay, is the key is not integer? So you need to have two functions. First, how to convert the keys into integer. Okay, so converting keys into integer, for example, if you have a key is A, okay, A is a character or a letter, then you need to change from A into integer value, and after you have the integer value, you can do the comparison function. So the comparison function means I want to change this integer into a particular value between 0 until n minus 1. So the hash code is applied first. Okay, the first one is applied first, and then the comparison function is applied next. Then we can have the hx, which is the function of h2 of h1. Okay. So the goal of the hash function is to disperse the keys in apparently random way. So you can just store in the random way in the table according to this function. So this function can be done by your definition. Okay, so you can have your definition for this hash function, but you need to remember that when you are doing with the hash code, so the hash code means you want to change the key into a particular integer. So when we want to interpret the memory address of the key object as integer, then it is good in general, except for numbering and for instead of numeric and string case. Okay. So the integer, it will be interpreted as a bit of the keys, and is suitable for keys of length less than or equal to the number of bits of integer. So when you are dealing with the memory address, yeah, it's good. Okay, it's good because the memory address have the values if integer, or you just give the integer case like this one. So you want to change into integer. Yeah, of course, you need to have idea how can you convert the keys into integer. Or sometimes we want to use like the component sum. So the component sum is the partition of bits into particular or fixed length 16 or 32 bits, and then we sum the component. And the suitable for numeric keys of fixed length greater than or equal to the number of bits of the integer type. So yeah, this is one of the way to do the hash code. So if you have the A and B, okay, so you convert A into bit component, and then you convert B into the bit component, and then you want to sum it. So that's also one way to do the hash code. Or you can also use the other way, like polynomial accumulation. Okay, what is polynomial accumulation? Yeah, you can have the A0, A1 until AN. Okay, if we have the partition of the bits, yeah, you can have the polynomial accumulation like A0 plus A1Z plus A to Z power of 2 and so on. Okay, and if you give with this kind of polynomial accumulation, then you need to understand what kind of values that you want to use. Let's say, for example, okay, I want to choose Z, yeah, as 33. Yeah. Let's say, okay, just it's an example. So if I choose Z equals to 33, it gives at most 6 collision of the set 50,000 English words. Okay, you know the English word like zoo, okay, zootopia, for example, okay? And then zebra. Okay, so everything with Z, it will have collisions, okay? And the collisions of those we will learn about the collision. Okay? And if you just representing Z, okay, actually there are about 50,000 English words with Z. Okay? Yeah. Anyway, the way to do with the hash code, you can just do with the polynomial accumulation. If Z is 33, and then if you have another, then you will have Z. This is 33 plus something, and then you will do with this polynomial. Okay. So this one is Z equals to 33, then 33 plus 33 multiplied by some, this is the Z is the 33, and then this is the particular coefficient, and then this is another particular coefficient, and then you can just use that power of 2. It is the way to convert from particular keys to integer. So the polynomial BZ can be evaluated in ON. So using the Horner rule. So yeah, it is just the rule in order to how many time that you need to do in order to get this integer code. And the other way for after you do the hash code is compression function. Okay? So the compression function, actually you can deal with the mode. Okay? So in the first part, I already explained to you, if we have the mode, it can be one of the function, y mod n. So n represent the number, the size of the list. And yeah, in many books or in the good book, it says that the n in the hash table is much better if you put it as a prime number. What is prime number? So prime number is a number that can be divided by 1 and the number itself. So like 1, 3, 5, 7, 11, 13, okay, those are prime number. So the reason has to do with number theory, and it's beyond the scope of this course. So if you ask me why, there's another explanation for that one, but I would just skip that one. So it's just use the prime number to indicate this n. And you can also do with a kind of functions, okay, multiply, add, and divide. MAD. So if I have the h to y, I don't want to use only mod, but I want to use ay plus b mod n. Yeah, that's also possible. And maybe you can have another requirement. For example, a and b are non-negative integers. So we have a mod n, which is not equal to 0. Otherwise, every integer will be mapped to the same value b. Okay, of course, yeah, you need to understand this idea. If a mod n is not equal to 0, then you will have a value of a. If a is 0, then it means it will always be, because 0 multiplied by any value will be 0. So using the hash table class, if you want to take a look on this hash table class, I think it's almost the same with what you see on the map. We have the length, get item, set item, tell item, but we have another method which is resize and hash function. So you can take a look on this one. This is the abstract of the hash table class. Now what we need to learn more about the hash table is the collision. What is collision? Okay, your bum. Okay, if you have cards and then you call it, Yeah, so it means just crash. You can easily think that the previous example, okay, the number, the keys are same, and they put all the keys into one particular index. For example, this one, 54, 28, 41. Okay, it will be placed in the index 2, okay, because we use this function. Okay? K mod 13. K mod 13. What is 54? 54 mod 13. Okay? 54 mod 13. Okay, so the result is 2. Okay, because the result is 2, then we put the value 54 into the index 2. What about 28? Okay, 28 mod 13. Yeah, so this is also, yeah, we have 2. Okay, so using the function, the compression function that you design, so there are some ways to deal with the collision. So we call this is the collision handling. Okay, there are some ways which is referring to the method to handle the collision. First is separate chaining. So in the separate chaining, we will let each cell in the table point to a linked list of entries that map there. So separate chaining is simple but requires additional memory outside the table. For example, this. A map with a separate chaining, it means I want to delegate the operation to a list-based map at each cell. So we have put, we have remove. What we have 3: get, put, and remove. In the get, I just want to get the value which is associated with the key K. Okay, and of course this one is HK. HK means the compression function. Okay, after I do with the compression function, I know what is the index, and after I know the index, then I would like to take the K. Put means I want to put K, comma V. I want to put those items. I want to put the item into a particular storage. Okay, so if it is if I put the key, comma V into T, so if the T is null, then we will do n plus 1. But if T is not null, then yeah, we will return the T. Remove, it means I want to delete. So I just want to exclude the item from the map. Okay. So this is the method. Okay. I guess I will not explain the detail because the idea is the same like what I explained before. We have the bucket, okay, bucket get item, bucket set item, bucket delete item. So yeah, those are the basic operation. Okay, get, set, delete. Okay, those are the basics. So they just implement into a bucket. Okay, so the bucket that I already saw before, that was an example in the collision handling. Okay. So there's another way, not separate chaining. Okay. In the separate chaining, it means we just want to put, remove, put, remove, put, remove. Okay. So you just put all the things into one cell. Okay. So for example, yeah, I have this one. Yeah. Okay. So if I have 52, and then I can just put 52. Okay. And then if I have, sorry, 54, 28. Okay. If I have 40, 54, 54, maybe this is the index 2. Okay. Okay, I can put here, and then I have another value, for example, 26. Because it is already full, then I just put into the next item. Okay, so that kind of separate chaining is available with linear probing. Okay. So what is linear probing? So the linear probing means after I do with the operation, the colliding item will be placed in different cells of the table. So the linear means just put on the next, just put on the next, just put on the next. Okay. So let's see. We have the compression function. This is x mod 13. I want to place 18. What is 18? Okay, let's see, I have one more. Okay, so 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, I have one more. Now I have 18. What is 18 here? Yeah, it is the key. So first you need to get the integer values from the hash code. So 18 mod 13. So we have 5. Then we will 0, 1, 2, 3, 0, 1, 2, 3, 4, 5. Okay, because here is 5 and it is null, then we just put 18. What about 41? Okay, so 41 mod 13, it will be 2. So we have 0, 1, 2. Then we can just put here 41. What about 22? Yeah, 22 mod 13, it means it is 9. Okay, so 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so we have the 22. So 22, the result 22 mod 13 is 9. Then we will put this one here, 22. Okay, what about 44? So 44 divided by 13, it is 5. Okay, 44 mod 13, and it is 5. But you can check here, 5 already fill in with 18. Then for the linear probing, it means I just want to put the value in the next available table. So in the next available table cell. So I put the value 44. Okay, I put the value 44 here. Maybe I can just this one is okay. I need to have more space here. Let me just separate this one, and this will be 44. Okay. Okay. Now next 59. What is 59 mod 13? So we have 7. Okay. What about 7? So there is no element in the 7. Oh shoot. I put this one. Maybe I need to delete that one. It's better. Okay. So what is 7? There is 7 here. Then 7 is none or null. Then we just put here 59. And what about 32? So 32 mod 13. The result will be 6. Okay. Let's see. What is 6? Oh, 6. Someone or a number already there. And then let's go to the next. 7. Oh, 7 is also already there. So we will go to the next. Now 8. Okay, there is no number on the 8. So we just put 32. And then what about 31? In the 31 is 31. We want to mod with 13. Then the result will be 5. Okay. How we can put this number 5? Oh, 5 already has a number. 6 already has a number. 7 already has a number. 8 already has a number. 9 already have a number. 10, okay, 10 is empty, and you can put 31 here. Okay, and then 73. So what is 73? 73 mod 13. What is 73 mod 13? So 13. Oh, multiply by 65 plus 78. Oh, okay. Yeah, so we have 65 Okay, so we have 8 actually. Okay, 73 mod 13 is 8. Okay, let's see what is 8. Oh, 8. There's a value in 8, and then 9. What? There is a value in 9, and then 10. Okay, there's also another value at 10. So we put the 11 at the index 11. Okay. So the result will be like this one. So this one is the result. Okay, this is a better representative. So I just rewrite here. So with the linear probing, your search will have a better way. Okay, so I give you this algorithm get k. If I have the k in the particular list, then yeah, you just repeat for every c in the AI. Yeah, I will. If it is not null, then if is this null, then return null. If not, then you want to get the key k and then get the values, and then you can do this repetition until p equals to n. Okay. So if we do the get a k, it means we start at cell h key and then we probe consecutive collocation until one of the following occurs. If an item in k is found, or if empty cell is found, or n cells have been unsuccessfully probed. Okay. So it's for the searching. What about if you want to update? Okay. So if you want to update, yeah, you can just do with the same search, okay, and you can just use the available value to replace the deleted items. So the remove k means I just want to remove the key k, and then after you have the k0 is found, we will replace with the special item variable, and the element will be O. Else we will return null. If you want to put the particular item k comma O, so we will throw an exception if the table is full. Okay. And we will start the cell at hk. So because we use the hash code, then we need to convert into integer. And we probe consecutive cells until one of the following occurs. So a cell I is found that it is either empty or stores available, and n cells have been unsuccessfully probed. So if those two conditions, either one is selected, then you will do that one. We store the k comma 0 in the cell I. So this is the hash table for linear probing. Okay. Now we have the probe hash map. I will not explain more, so you can take a look on this code. Okay. The other collision handling, we call it the double hashing. Okay. So double hashing is a way to deal with the collision. So if in the linear probing, you can just put on the next, on the next, on the next, on the next. Okay. So if there is no way to put on the if the item is full, and the problem is if you put a value into, for example, before you know the 5, right? So if you want to put here, okay, you want to put 5 in the index 5, but 5 already full, 6 already full, 7 already full, 8 already full, 9 already full, 10 already full. So we can put on the 11. It means the operation will keep going, and yeah, it will, the worst case might be related like log n, okay, because we will not do until n times. At least we have log n. Okay. But if we are doing with the double hashing, it can be more efficient. So the double hashing here, we have the first hashing, which is, for example, yeah, the first available is just using the I plus jdk. So dk means the double hashing, and then we will do mod n. So n, as I mentioned before, it is recommended to have n as a prime number. Okay. So if we don't have any issues, you can just use the j equals to 0. But if the I mod n has issues, then we can try to use the dk. Dk is the double function, the secondary function. So the dk, yeah, the common choice or conversion function for secondary hash function is like this one: key minus k mod q, where q is less than n and q is a prime. So the possible value for d to k is 1 till 2 and until q. Okay, so let's see one example. In the previous example, we have the only this one. Okay, we have only this one. So I have only the n k mod 13. But now with the double hashing, I would like to think more efficient with the tk. So this is the double function. If it is call it, okay, if it is crash, then let's do the tk. So let's see, 18. What is 18? Mod 13. Okay, 18 mod 13 is 5. Okay, let me just have another. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 18 mod 13 equals to 5. So we have a 5 here, and then just put 0, 1, 2, 3, 4, 5. Here is 18. What about 41? So 41 mod 13, it is 2. Okay, so I don't need to use the tk because I just put on the index 5 and there is no value on the index 5. What 41? Okay, oh, I already have this one. 41 mod 13 equals to 2. So is there any value on the 2? No, then I just put here 41. What about 22? Okay, 22 mod 13. Okay, I don't need to calculate this one. Okay, 22 mod 13 is 9. Okay, because I have 9 here, then you can just put on the index 9. Okay. What about next 44? 44 mod 13 is 5. Okay, you can check. Oh, 5. You already have the values. Now we will go to the next dk. So dk, now j not equal to 0, but j becomes 1. The value is 5. Okay, now we have I is 5 plus j, now it becomes 1 multiplied by dk. What is dk? Dk is this one, 7 minus k mod 7. So k in this case is 44. Okay, so 44 mod 7. Yeah, we have 2. Yeah, we have 2. And then 7 minus 2 will be 5. So we have 5 in the second one. Oh, then yeah, of course you don't need to worry because now you have also the same values. Okay, that might happen because I already have the value in the 5. Then I will just do with the next number. Okay, so in this case, I have the I. What is I? I is the result of the I plus jdk. Okay, so because we have 5. Okay, we have I equals to 5, and then when j equals to 0, so I just have 5. Okay, and then if I have j equals to 1, so it means 1 multiplied by 5 plus 5. Okay, so 5 plus 1 multiplied by 5, then we will have 10. Okay, so because we have 10, then you just put this value into the index 10. So the result will be here is 44. Okay, so the 44 will be in the index 10 because once you check in the 5 is not available, you check with the dk which is 5 also not available, then you increase the j. Okay, so in this case j is just 1, so now we are having 2. So if we have 2, then yeah, we have the second one, which is 10. So we can have the value of 44 in the 10, and then next 59. So 59 mod 13, it is 7. Okay, is there any number in 7? No, we just put 59. Okay, and then 32. What is 32? 32 divided by 13 or mod 13 is 6. Okay, so here we put 32. Okay, and then we have 31. So 31, we okay, it's 5 again. Okay, so you don't want to call it, you don't want to crash with this one. So I have another decay. So the decay is this one. Okay, 7 minus k mod 7. So the result will be 4. Okay, but what is 4? Oh yeah, I have this 4. It is to do with the probing. Okay, 4 plus 5. Okay, and then the result will be 9. So let's check what is 9. Oh, I already have 9. So in the 9, there's already a value here. Then I can do. So what we can do is just go to the next, which is 0. Okay. Well, so because I have 5 and then 9 and then 1, 2, 3, 4. So it will go to 0. Okay. So this one, yeah, it will be because of this one 4. After 5, we have 5 plus 4, 9, and then 9 plus 4, which is 0. So that's why we can just put 31 here. What about 73? Okay, in 73 divided by 13 or mod 13, it is 8. So in the 8, there is no value, then you just put 73. Okay, so this idea actually, yeah, if you take a look on this one, it will be the value of this one, double hashing. And yeah, with this result, the performance is much better, because in the linear probing, when you cannot find any place, when you cannot find any empty place, you will do the next. So the operation time will be longer than this one, because if you do with the next, you will take more times than you do with this probe. 5 plus 5, then 10. So you just put in 10, and then 4 plus 5 is 9, and the 9 you already have the value, then just do one more time. 4 plus 9 mod 13, then you will get to 0. So by using this very simple way, it will help you to do more operation when you use the hash table. So the performance here, what we want to say is, in the worst case, the insertion and removal will take on, and the worst case, when you insert the key, so it will take like the value of the alpha, which is n, small n divided by n. It will be the performance of the hash table. Okay? So assuming that the hash values are like random numbers, it can be shown that the expected number of probes for an insertion will, with open addressing, is this number. Okay. Yeah, if you do with the evaluation of the load factor and etc., then you will expect that the dictionary ADD in the hash table, it will run O1. Okay, so whenever you put the value in the particular index, yeah, everything it will be O1. So in practice, hashing is very fast, provided the load factor is not close to 100%. Yeah, if you understand how to put that one, yeah, it's very fast. Okay, especially when if you insert. For the removal, yeah, it's the worst case, it will be ON. So the application of hash tables, it can be for the small database. If you have small database, you can just assign in a particular address, or compilers or browser caches. I think that's all. Okay, if you still have some doubts, or if you cannot understand clearly, then you can just feel free to email me. So I can try to help you to make it to understand the concept of the double hashing and the linear probing. So thank you very much for listening.